something I primarily entitled TBA, which means two-word Boolean analysis. You can see in the program. However, in the meantime, I've given more precision to the title, and I decided to propose what you can see here: minimal change strategy and connexive logic. This is the topic of my presentation. The content, in short, is as follows. I will try to talk about classical logic and non-classical logics, proposing something like solar system of the logics. And I will outline what is minimal change strategy. Finally, I will try to place connexive logic as a contra-classical logic and to show the application of minimal change strategy to some family of contra-classical logics, connexive logics. First, some basic notions. We will work in the language of classical propositional logic, variables and for operators, the set of formulas for, the set of all theses of classical propositional logic will be denoted as CPL. Of course, CPL is a proper subset of for. CPL can be differently determined, as we know. There are many techniques, including semantic ones defined by Boolean valuations. Let me mention that 3 of the operations are Boolean, while 1 is not Boolean. I mean material implication, which is expressed by the condition imposed on valuations, you can see. I will use also some abbreviation. This is what we call sometimes material implication, but in fact in the language it does not appear. We have just negation of antecedent in some disjunction with succeedent. Some typology, logics. By logic, I will mean such a subset of for that is closed under substitution function. There's the set of all substitution function. So it means that I have a very liberal definition of logic. What is non-classical logic? Non-classical logic is a set of formulas, which is a logic, of course, but is different than CPL, so the set of all classical theses. Of course, it includes also the case of trivial logic, but I will not refer to it as it is trivial. So I'm interested rather in non-trivial, non-classical logics. Now it's time to say something about subclassical and contraclassical logics. What is subclassical logic? I will call a logic subclassical if it contains only classical laws. So logic set minus CPL is empty set. Then I call logic subclassical. Well, when logic is contraclassical, it is exactly when the set minus of CPL is non-empty. It's not empty, which means that in fact that in L, at least one, which in fact means infinitely many formulas that are non-classical theses exist. So subclassical, contraclassical. I don't want to speak about subclassical logics, but I've written here the definition just to compare subclassical, contraclassical. How non-classical logics, how they, let me say, are created. We have, from some point of view, I'm presenting here, we have two strategies, two possible moves we can make. First is we just remove some theses of CPL. And second, we add some new theses of CPL. Of course, usually both moves are, let me say, equipped with some additional techniques or moves. For example, when we remove from CPL all formulas of the form A or non-A, we will get some subclassical logic, but it will be not closed under modus ponens. If it is closed, it will be not, of course, subclassical in a strict sense, because it can be deduced from other theses, etc. So we must usually remove something and do something additional. But the first step is to remove something. And the second strategy is just to add something. It's like we can to CPL add formulas of the form of the first Aristotle connexive law. However, still we must do something more if you want to avoid trivialization. We can look, this is some, let me say, first glance, we can look at the strategies like at some operations in belief change theory. Yes, there is something like contraction, revision. We add something and change the data. We remove something and also we must change a bit the initial data. We can look at all possible results of the strategies as we can look at it as at some, let me say, solar system. I intentionally use the term solar system because we are celebrating the 550th anniversary of the birth of Nicolaus Copernicus. That's why we can use this metaphor to commemorate this, let me say, anniversary. However, look that when we talk about other logics defined on the language we introduced, we say about non-classical, subclassical, contra-classical logics, which means that we assume CPL as some kind of the point of reference. So we can treat CPL as some sun and the non-classical systems as some planets that revolve around the CPL. Now, if we have some solar system, this is interesting question about the distance between planets and the sun. And we can use different definitions. I can start with the definitions you can see here. For example, if we have two subclassical logics, L1, L2, we can say that L1 is more classical than L2 if L2 is contained in L1, because it means that L1 can have more classical theses, so it is close to the sun. In case of contraclassical logics, you can assume such definition that L1 is more classical than L2 if and only if intersection of L2 with classical logic is included in the intersection of L1 with CPL, which means that all classical laws that are contained in L1 are also laws of L2. But maybe L2 has more classical theses, which means that it is close to CPL. So the distance is shorter. Of course, we can talk about strictly more classical or less classical, taking the inverted relation and define the orders on this solar system. Now, having this, we can introduce something I would like to call minimal change strategy. There is some in science golden methodological principle called Ockham razor. In short, it says that to give explanation of some facts, we should use so many beings in our theory as it is necessary, but not more. We shouldn't multiply notions, objects, relations, and other theoretical objects. We should try to be rather mean in that context. Minimal change strategy is a variant of Ockham razor. We can formulate it as follows to obtain new things in our situation thesis. A change of starting point, we start from some point. As we said, the reference point is classical logic. Should be changed only as far as it is necessary to get the new things we want to have, but not more. So we shouldn't make the distance between classical logic and the non-classical logic. Shouldn't make it farther than it is needed to get the point we want to have. This is minimal change strategy. How we create usually in contra-classical logics? We start from CPL, consider some new formulas. They must be contingent or counter-valid from the point of view of classical logic. We remove such formulas that provide trivialization after adding A1 to AN. And with some rules we also impose. Now we add the new thesis and close the result under the rules of inferences we want to have. And 5, then we get some contra-classical logic, since at least A1 from A1 to AN belongs to the logic, so this set minus is non-act. But we can also evaluate the process of creating contra-classical logics. Let us assume that we are interested in the formulas from A1 to AN. Let us assume that we have two contra-classical logics, L1, L2, created in the way I presented, but probably by removing something also. Now we can compare them. Let L1 be more classical than L2. Since both logics include laws A1, AN, the logic L1 is better from the point of view of the minimal change strategy. The logic L2 is less classical, so it satisfies like less classical thesis. But maybe L1 is still not classical enough. Maybe there exists a contra-classical logic L1 prime that includes the same thesis we want to have as thesis, but still is more classical than L1. Definitely, there exists a maximally classical, always maximally classical contra-classical logic L that includes the thesis, and so it is more classical than, in this improper meaning of being more classical, than L2, L1, L prime 1. L is included in the set of the best contra-classical logics that include A1 from A1 to AN, because it is the most classical, but non-classical, of course. This is because in that case, we did or we have done only what was necessary to do, not more. Maybe there is exactly one such logic. Maybe there are many maximally classical. This is what generally cannot be checked. Now we can go to connexive logic. Connexive logic is a kind of such contra-classical logic in which we have some new formulas we would like to have as thesis. From the classical point of view, all of them are contingent formulas. Contingent. This is another interesting distinction. I haven't done it here. We can also try to make some typology of what kind of theses are introduced. You can, for example, say that if somebody introduces contingent formulas, it is more classical than counter tautologies, because it is farther from classical logic. But let me leave this aside. Now I'm keeping the typology I presented. So we have 4 theses. Of course, these are schemas of theses. Sometimes I will talk about schemas, sometimes about theses, but I know that the audience are professional logicians, so they see differences. Look at this, the smallest connexive logic. What is the smallest connexive logic? Let us just take, if we treat schemas as just sets of the formulas that have this form, we can make a union of them. And the smallest connexive logic is the logic, which is just a union of all 4 sets. Of course, it is not closed under modus ponens, that's true, but who said that it must be closed? If we resign from some classical thesis, we can also resign from some standard inference rules. So this is the smallest connexive logic. When you close SCL, smallest connexive logic under modus ponens, we get something more. This is SCL prime, since it will contain some new formula. But both SCL and SCL prime are very far from CPL. In fact, they do not contain any classical thesis. So they are at the end of the solar system. At the end. But this is a good point to making the logics closer to the reference point. Towards CPL. Probably there are different strategies. I would like to talk about one of the strategies we have been introducing, examining, and working on for a few years. One of the strategies to be close to classical logic, and also to be close to the minimal change strategy, is to define what we call Boolean connexive logics. Boolean connexive logics, BCL. They are intended to be very close to classical logic, but at the same time to be connexive, which seems impossible at the first glance, but it is possible. Different semantic strategies were proposed to get the logics. The oldest is the relating semantics. The new ones are point 2 and 3. Point 2, set assignment semantics, was used by Louis and Mateusz Konowski, with some variant of being included in USA, which is the abbreviation for uniform set assignment. In the first work on set assignment semantics, or one of the first papers, there was some assumption about uniform set assignment, that the set assignment to the formula is just the union of assignments of the assignments of the subformulas of the formula. Here in this approach, the colleagues weakened the assumption. There is only inclusion, not equivalence. But there is possible also other strategy of applying set assignment semantics, a variant we call cautious and disjoint assignment to literals, not to variables, but to literals. This is under preparation by some team, Nicolo, Francesco, and me. So we know 3 strategies of getting BCLs. Let me concentrate on the first strategy. The first strategy is based on on relating semantics. This is some semantics which is, let me say, now growing. Several people are interested in doing different things like meta-theoretical research applications and organizing some events, etc. The main idea in the simplest case is that the relating connectives, so connectives that require relating models, need two factors, two things. The first, of course, logical values, as usual, but the second, it must be supplemented with evaluation of the relation between these components. This is a new element, that we have evaluation between components, not only evaluation of the simple sentences, but also the evaluation of some connection between sentences. This is the main idea. There are many variants, many more complicated structures, etc. We will be close to the very simple implementation. So the model is just a tuple relation defined on Cartesian product of formulas. This is how we evaluate connection between two formulas. If the relation holds, they are connected. If not, they are not connected. And the second element is just standard evaluation. Variables are either true or false in the model. This is in fact not a model. Somebody would object, and then I would have to agree this is some structure. It becomes a model when we add some truth conditions. And these are truth conditions for the case we are working on. This is the case we call Boolean logics with relating implication. Why? Because the operators, Boolean operators, are in the model interpreted classically, variables, negation, conjunction, disjunction, while implication is non-classical. Non-classical because to the condition, standard condition for material implication, we add some filter or something that can be called in that way. B and C, antecedent and succedent, must be in a model related in this relation, which is included as the first element of the model. We have, because this is just, when you have more elements, you have more combinations. So now we can define different semantic notions like being true in a model, being true in a relation, in a group of models, a set of models, and a set of relations. So of course, in a model, being true, we defined. Being true in a relation is something like being true in a frame in model logic. So for all evaluations, it means being true in a relation. Being true in a set of relations, we use some superscript. A set of relations means being true in any relation that belongs to this set. This relation, because we talk about being potentially a valid formula, the relations are more complicated when we talk about consequence relations, but I intentionally omit here the problem of consequence relations. So I started and I'm talking about logic as a set of theses. But the relationships between models and relations have been intensively examined in some paper of me and Mateusz. What is important here, on the level of valid formulas, there is no difference between relations and models. So if you have some set of relations and you have some models that are based on the relations from the set, and you take all possible variations, you have the continuum variations of propositional letters. So you get exactly the same set of theses, of valid formulas, better to say, yes, because it is semantic of valid formulas, according to the set of relations as well as the set of models based on all relations from R. Some facts on Boolean relating logics with implication. There are some special relations, usually they appear when we consider the theory of relations. In general, universal relation. There is only one universal relation, so the set of all universal relations is a singleton, and universal relation in that language define exactly classical propositional logic. So when everything is related or connected, then we have a case of CPL. On the other hand, when we have empty set of relations, not empty relation, there is a difference, not empty relation, but empty set of relations. Because empty relation is also a special relation, and it defines some, let me say, very contra-classical logics, where all possible implications are just invalid, and their negations are valid. So this is, let me say, some extreme case. We are talking here about empty set of relations, and empty set of relations by this big quantifier and empty set gives us just trivial logic. So all possible formulas are valid formulas in such structure. Now we would like to impose some conditions on BCL to get BCL. Many times we talked about that, so I won't to waste your time on this detail too much. When we impose from A1 to B2 5 conditions on R, on the relation R, and we take all models or relations, as I said, that satisfy the 5 conditions, we get what we call connexive logic. We can call the set of all relations that satisfy the 5th conditions. We can denote it, namely by R con. Yes, if the set of all relations that satisfy the conditions is R con, and in R con, all connexive laws are satisfied. However, this is not interesting, as we see, it is not difficult to define connexive logic. But special feature of this logic is that for all formulas from CPL, so all theses of CPL, if the main connective of A is not implication, this is also a thesis of the logic determined by R con. That's why the logic is called Boolean connexive logic. Being at the same time connexive is also Boolean for Boolean operators. The logic defined by the set R superscript con is the smallest BCL. The question about axiomatization was answered by Mateusz Klonowski, who provided the following axiomatization. So we have substitution of the language of classical tautology, any substitution of any classical tautology in the language without implication. So the language that contains only Boolean operations. Our Aristotelian Bayesian laws. The important axiom I call weakening axiom, and disjunctive syllogism. Here you can see. Of course, by it we can also prove the modus ponens for the connexive implication. This is the axiomatization of the smallest system. Let me look at the time. Okay. So the smallest B cell of this B cell is a connexive logic. The logic is maximally classical in the fragment of language negation, conjunction, disjunction. So this MCS is so strongly applied here because we have all laws for those 3 operators. So we are very close to the sun, but not, of course, fully, because we don't have classical laws for implication. As we know, it is impossible to have all of them because then we will get the trivialization. But we can try to be closer and closer. MCS in application to BCL can be summed up by the following aphorism. What is Boolean remains Boolean. So the three operators are still Boolean. What is not Boolean becomes connexive. But the word belongs to the brave man, so we would like to go. Some people want to go to Mars and would like to go to the sun. So let us go more classical. And we would like to define a logic that is stronger than the smallest BCL, stronger in that sense that it belongs to more classical laws. So it has a shorter distance to the classical logic. It's more classical according to the terminology I introduced. And it seems that a good strategy is to start with universal relation, which defines, as we said, the CPL. And of course, it is too strong. It must be weakened by us by some techniques. And we can try to weaken the relation, for example, like here, that we take the set of all maximal subsets of relations are sets, as we know, sets of binary relations are sets of pairs, ordered pairs. So we can take all maximal subsets of RU, universal relation, such that satisfy the counterparts of the Boolean connexive constraints imposed on the smallest BCL. If we do that, we get some a set of Rmax, the set of all relations that satisfy the conditions. Of course, it can be empty, which is not good because if it is empty, it could define the trivial logic. We don't want we want to go to the sun, but not after the sun. Yes. So we know that if we define the set in that way, max is non-empty. It satisfies connexive laws, and that means the strictly more classical BCL than the smallest one. So we are closer to the CPL, but our hypothesis is that Rmax does not determine the maximally classical connexive logic. But of course, there exists maximally classical connexive logic of the type we are working here on, but it is not the logic determined by Rmax. And this is the challenge. Define the set of relations R that determines the maximally classical and non-trivial, of course, connexive logic. So it is not empty, gives the validity of connexive laws and validates as many as it is possible classical laws, as many that adding a new one trivializes the system. This is the challenge. Maybe this is the challenge not only for us. Anybody who proposes some connexive logic can try to find a maximally classical variant of his logic. The challenge is difficult, and the answer is hasn't been clear yet. We are working. This is some definition that we changed. We changed one condition. This is the third condition, referring to the universal relation. But still, it is not good definition. The hypothesis is that we should use some chain of relations in which we always refer to the formal relation or union of the formal relations in the third condition. But it must be checked. So what I can say now is the hypothesis that the set of relations defined by this definition is a good starting point to find a demanded set, which determines this maximally classical connexive logic. as close to the CPL as it is possible. This is the literature we have, and that's why. That's all I wanted to present here. Thank you for your attention. I think nobody has heard me because there is no feedback.
Who wants to begin?
Yes.
Yes, Henrik. Yes.
May I see the person who is asking, because then I can read also from the face what is the question, okay?
But Tomasz, we know each other very well, so we can imagine my face.
Okay, I know very well your face. It looks very good and nice. Okay.
Yeah, and also I say it's good to
very friendly. It looks very friendly. Okay.
Can I see? I can see part of it. Okay. So I have some questions. One question came up very early on during the talk. So you define a logic as a set of formulas.
Yes.
But this is just one option, and choosing this option means that you cannot draw a distinction between the logic of paradox and classical propositional logic, because they both have the same set of theorems. And FE has no theorems. So why did you choose to define a logic as a set of formulas?
Okay.
Instead of a set of a relation.
Mm-hmm. Okay. This is the last question, or you have one more?
I would like to ask them one after another.
Okay. So, thanks for this question. I am doing this for one, let me say, obvious reason. This is because, first, this is simpler than to deal with consequence relation, as this is simpler. Yes, I must admit, but I must say that this is not the end of the project, this is the beginning. So our group is going to extend this to the consequence relations. That's obvious, but as a starting point, it is, let me say, more convenient to deal with sets. So you are absolutely right. We should do that, and we will try to do that in the future when we make some order in the set of sets. But the second reason is that this is, let me say, quite similar to modal logic. But I know that modal logic is a special case, yes, special case, and it is natural to treat logics as sets of theses. So yes, you are right. I agree with your objection that it is too weak. Thank you for that. Sure.
And then my second question has to do with methodology. I mean, the challenge.
Typology, yes.
The methodology. So, I mean, the challenge you presented at the end of your talk, I think it's perfectly okay as a research problem. But then this talk about classicality, subclassicality, contra-classicality, I think this is just historical coincidence. That I mean, the first textbook on classical logic appeared less than 100 years ago, and if you look into the history of logic, then classical logic is not so obviously classical. And if one is really serious about the system of not classical or contra-classical logic, then it's not clear that really classical logic is the center of the solar system. And actually, I have a paper with Sergei Odintsov on the methodology of consistent logic, where we argue against using classical logic as a reference system. So I think the mathematical problem you're posing, it's perfectly okay as a research problem, but picture where classical logic really is the center of a cosmic system, I think it fits on perfectly.
Okay, let me say something like that. I can also agree with that point with you. However, other systems of logic can be also treated as some sums. Yes, somebody else can start from some other reference point and treat this as a sun and look at other systems like planets, yes, and compare to other systems. However, whatever we take as the, let me say, reference point, I think it is good to have one, yes.
So you would agree that it would also make sense to think of other logics as reference points and then ask similar questions until you're posing a new challenge?
Sorry, I didn't hear the last part of your.
So, if I understood you correctly, you are not so dogmatic that you would say yes, the classical logic is the center of the universe, but you would also admit other systems as.
Yes.
Okay, I'm happy to hear that.
Great. So Damian is next. Please.
Yes. Okay. Thank you, Tomasz, for the talk. I really enjoyed it. And my question is also related to the challenge. So I wanted to ask you whether you think that this challenge can ultimately be met. And by this, I mean, do you think that there will be only one maximally logic, or maybe some options, like there will be a family of maximal options, but not single? And then perhaps as a follow-up to that, just in your discussion with Henry, I was thinking, could we think about many logics that we would like to approach connexively, right? For example, intuitionistic logic. So we will perhaps want to have intuitionistic connexive logic.
Okay.
And maybe it will be interesting to think whether some of them have a maximal option and some of them, maybe there are many maximal options to approach connexive relatives to them. Mm-hmm. These are the questions. Thank you for the talk.
Thank you very much for interesting question, and thank you very much for your voice. I've never met you, but I know about you. So
thank you.
The first time talking. So that's why, to the first part of the question, that's why I use the term maximal, not the most classical, yes? Because it can be more maximally classical. Let us replace classical by, let me say, logical, yes? Well, logical means close to some logic you treat as the reference point. Why not? So, maximally logical or most logical? As we know, this is a problem of set theory. It can be more maximal subsets, not only one that satisfies some additional conditions. But it is always interesting to prove that there is one maximal, which means that this is the most logical in that case. But generally, we don't know. Okay. The second, yes, do you agree? So I let me say, do not decide if there are only one, but always I must say that there is some maximally, in my case, classical logic. Yes, at least one. But it doesn't mean that we can give axiomatization, finite axiomatization, etc. It means that there exists a set of theses which is trivialized when we add one more. The second part of the question about another reference point, as far as I understand, intuitionistic logic. That's good. Somebody can create the solar system around the intuitionistic logic. But this, let me say, example is not, let me say, out of the scope of the CPL solar system, because intuitionistic logic is a subclassical logic. So, trying to be close to intuitionism, probably you are also close to CPL. But it doesn't matter. You can take any logic and try to maximize your connexive logic to be as close as it is possible to that logic. Then you can say that you, from the other side, that you take the logic which is the reference point and you weaken it only as much as it is necessary to get connexivity. Yes, you can say this. If you have this maximally logical, maximally, let me say, intuitionistic connexive logic or something like that.
Thank you very much.
Yes, do you agree?
Henry wants to jump in.
Then I would suggest to rephrase the challenge, because there you use the definite article define this set of relations that determines the maximally classical logic. This would presuppose systems and unities. So I think it would better to have a set of relations that determines a maximum.
Better to use instead of maximal, what word?
To use the indefinite article instead of the definite article.
A maximal, yes, a maximal. Okay, that's good, a maximal. I use usually adverb, maximally classical, yes, maximally classical. But still, okay.
Yeah, Henry said also that you should also the indefinite article for the set of relations. There can be
not necessarily, it depends, yes, because if we take the set of all relations that satisfy some condition, there is the unique set, yes? So then we use the set of all people, not a set of all people, but the set of all people.
Okay, so Andrew is next.
Yeah, actually, just on that point, I mean, I think there's a way of making the challenge more, or also interesting along these lines, is to give some sort of characterization of all of those sets of relations that give you the maximal classical and non-trivial connexive logic, so that it turns into sort of a characterization problem. Like, what do your relations need to look like in order to generate this? In which case, you know, the fact that there might be multiple maximal elements is sort of interesting as a way of like chopping up the set of all the possible relations into those that give you them and why those ones are the maximal ones. I think this serves to make the challenge more interesting than it already was, which was interesting to begin with. So.
Okay, but by using the relations, I just propose some techniques which is interesting to me to maximize the logic, but somebody can use other techniques, yes? It is not about using that technique. Everybody can choose some technique, yes? By adding some axioms or additional rules. I don't know. This is the technique I like and I feel comfortable by use of that, but this is only a bridge to maximization, not only bridge probably.
Hi, Tomasz, by the way.
Okay, so thank you for your good, interesting questions and for your patience and, as always, kindness. I feel very honorable to be with you, even if not physically, but still I feel the spirit of logic here.
Yeah, the spirit is present. We still have a little bit more time for some other questions or comments. Yes, Sandra.
¿Puedo preguntar en español y no traduce? Bueno, si es posible tener una lista conexiva humana y pues dónde está como dentro de la complejidad y la clasicalidad.
Okay, so Sandra is asking where's the frontier between classicality and connexivity when we talk about Boolean connexive logics. She's actually asking as well if they are possible. Maybe you can give some comments to her.
The question is about the difference between you said connexivity and
classicality.
Classicality. No? As I presented, the part without implication is absolutely classical. We call this Boolean because real Boolean operations are negation, conjunction, disjunction. Implication is not a Boolean operation, and never was. So usually it is used as an abbreviation. But if it is an abbreviation of negation and disjunction, it must, let me say, behave classically. If you want it to be non-classical, you must treat this as an independent operator, not definable by a simple operation, but with some additional new meaning. This is the difference. The Boolean part is still Boolean. Non-Boolean part can be Boolean, but doesn't have to be. Can be non-Boolean, which is the let me say, open space to define different non-Boolean, non-classical things. But then the problem arises how to be non-Boolean, but as close to Boolean as you can, avoiding trivialization. This is the let me say, outline of the problem, of the space we are in. Let's go. Okay, so thank you very much for questions. Adios, adios.
Okay, so let's thank you, Thomas.
Thank you very much. Thank you for your passion. As I said, have a good and fruitful lectures.
Thank you.
See you. Bye bye.